Good morning, friends. Welcome to my course, Flight Mechanics. This course belongs to the 4th semester of Aeronautical and Aerospace Engineering at Department of Aeronautical Engineering, IARE, Hyderabad. I am Dr. Yagya Dutta Dwivedhi, Professor from Institute of Aeronautical Engineering, Hyderabad. Today I am going to discuss about introduction and course description about this flight mechanics introduction and course description about this course. So as of now, we have seen that aircraft wings are producing lift, also drag. But how much lift and drag it is produced? The ratio between lift and drag, that is called L by D ratio. This ratio is the main parameter for aircraft performance. If you see any phases of the flight, we have the different phases of the flight, like here. These are the phases. So it is a ground run. It is a ground run. From here, aircraft will climb. This is the climb. From climb, it will be cruise. Aircraft will be cruising from long distance. From cruise to the next destination, it will start descending. Then it is loitering, again descending, and this is the landing. This is the descent. This is the loiter. It is called the loiter. So aircraft is here on the runway. Here is your aircraft, assume. It has to run here. After running and it is getting some required speed, aircraft will take off and then it will climb. This is the climb phase. This is the ground run phase. And up to certain height, this is the altitude. This is the altitude. It will reach to the certain altitude, and after reaching here, it will maintain the same height. And this area is more than 85 to 90% of the aircraft will be in the cruise condition. And when you are about to reach to the next destination or in the same return in the same destination also, you have to start the descending. And after descending, if air traffic controller is not permitting you to land, then aircraft will be circuiting around the airport. This is called the loiter. Number of turns it will perform the aircraft at a given area or zone. And after that, the clearance from ATC, from here onwards, aircraft will start landing, and then here it will be parked. So these are some phases of the flight. This is called the phases of flight. So if you want to see about the aircraft performance, we can also compare with the help of a four-wheeler or the car or the bike. So if you want to buy the bike, we need some specification like speed, then pickup, then maintenance, then cost, then price, and same, that is the range, style, and so on. This is for the your four-wheeler. Same way, here for aircraft, we want max speed, rate of climb, endurance, range, maneuvering, climbing, maintenance, landing, landing distance, and so on, etc. So many things are there. They are the part of aircraft performance. So this course, flight mechanics, here we will be handling the aircraft performance part. So this will give that how much our aircraft can perform in a given situation. But in this class, I am not going to discuss about these all things. Just I gave some introduction about aircraft flight mechanics, and I will see that how the course description of this course is assigned, that I am going to discuss in this section. So these are the contents for the today's discussion. So that is introduction to outcome-based education, discussion on course description, course objectives and course outcomes, introduction and the historical background, scope and application of, this is you can say that, flight mechanics. So just I will go with the levels of cognizance and the Bloom's taxonomy. The Bloom has given some special verbs for the cognizance level of the student, how they can approach the system. If you see this triangle, we have here the first one is the remember. The remember is the lowest level of cognizance. In this, the student should recall facts and basic concepts such as defining any things, duplicating things, making the list of items, memorize the things, repeat the given statement, etc. And this is the lowest level of understanding, which is not suitable for a college level students. This can be for the school level from first, second, third up to 10th. This is okay. But as you go above the level, your triangle is also getting reduced. And here the remember level is very big. Most of this area fall in this group. Next level of this thing is the understand. In understand, the student is able to understand the concept. They can able to explain ideas or the concept, like classification, description of anything in own words, discussion of any topic, explanation, identity, locate, recognize, report, select and translate. Like these things will come in this group. Then further level is increased to apply. Apply falls within middle of this thing. Our engineering students should most be in this group or above. That is the required. In this, we should use the information in a new situation, which you learn from the remember and understand. Whether you are able to apply in a new condition, new situation, then only you can, if you are able to understand properly, then only you can able to apply the things. Then analyze. After in the apply, we have some verbs like execute, implement, solve, use, demonstrate, interpret, operate, schedule, sketch, and so on. If you think about the analyze, it is the result which after application you got some result, whether you are able to do proper analysis as per the recommended system or not. In this, draw the connection among ideas. Whatever you have understood and you have applied, and you got some experimental result or some tabular form or some figures are there, whether you are able to do the analysis or not. So in this, we can have some verbs like differentiate, organize, relate, compare, contrast, distinguish, examine, experiment, question, and test. They fall under this group. Then if you, next higher level is a evaluate. After doing the analysis, where we have used our thought process, then we have to justify a stand on the decision. Because in analysis, you might have got so many things, which is more, which is less. Like this, you might have got so many things. Out of that, whatever required for our objective, whether we are able to meet that thing or not, whether we are able to justify the analysis which we have done, out of that we got some result. That result has to be justified stand, and then only we can take the decision that which one is the best solution for that problem. In that, we have some verbs like appraise, argue, defend, judge, select, support, value, critic, and weigh. These are the few verbs which are to be used for evaluation process. This is the second topmost level of cognizance, and the higher level students will reach in this zone. Then the final zone is the create. After remember, understand, apply, analyze, and evaluate. If you do all the things, whether you are able to make the product, so produce a new or original work. Whatever existing, it is not thing, whether you can do something new or not. In this, some few special verbs are there. They are design, assemble, construct, conjuncture, develop, formulate, author, investigate. Author means writing the paper. Formulation of something new. Develop some technique, some methods, some product. This is called development. So if you can do something new which is not existing, that is the creation. It doesn't mean that you make one aircraft, then only it is the system, or it is you are creating. You can make some paper, you can make some thesis, you can make some report, you can do some new things. That is also part of creation. So the objective of our teaching learning process of this OBE system to reach to that level. All students may not reach, but sure that few of the students of BTech will surely reach up to the evaluate and the create level. So please do as per that. Now we have some course overview about this flight mechanics. So flight mechanics is the science that investigates the performance of aircraft as applied to flight vehicles, and to provide a clear understanding of related topics, specifically on aerodynamics, propulsion, performance, stability, and flight controls. The course introduces the fundamental principles of aerodynamics and propulsion for aircraft performance in classical flying stages. Just now I have discussed that we have the ground run, then climb, then cruise, then descent, loiter, landing. These all stages are there for the flight. This course is the point of confluence of other disciplines with aeronautical engineering and the gateway to aircraft design. So this is a brief course overview about the flight mechanics. To have this course, we have some objectives. So the main three objectives are persisting in this: the fundamental principles of aerodynamics and propulsion for aircraft performance in classical flying stages, the different regimes of aircraft and performance requirement at various atmospheric conditions, the mathematical models for various types of maneuvers, safety requirements during takeoff, landing for better performance and stability. So these are the three major objectives of this flight mechanics. In this, we have some 6 course outcomes. So students should be able to do this all things. We have the CO1, demonstrate the mission profiles of simple cruise, commercial, transport and military aircrafts for getting the airplane performance characteristics. Explain the cruise performance of an airplane in relation with range and endurance with different types of aircraft engines. Identify the effect of constant angle of attack, constant Mach number and constant altitude in cruise performance for notifying the minimum maximum speeds in flight. Apply the concept of climb descent performance along with energy height, specific excess power and energy methods for achieving optimal flight conditions. Develop the aircraft maneuver performance to perform in turn, pull-up and pull-down maneuvers by considering limitations of power for military and civil aircraft. Compare the various landing distances such as discontinued landing, bulk landing for better stability and control of the aircraft. So these are the few course of outcomes which every student should obtain after going through this course. The syllabus consists of Module 1, 2, Module 3, Module 4 and Module 5. Module 1, we have Introduction to Aircraft Performance, that is the role and design mission of the aircraft, performance requirements and mission profiles, aircraft design performance, the standard atmosphere, off-standard and design atmosphere, measurement of air data computers, equations of motion for performance, the aircraft force system, total airplane drag estimation, drag reduction method, the propulsive forces, the thrust production engines, power producing engines, variation of thrust, propulsive power and specific fuel consumption with altitude and flight speed, the minimum drag speed, the minimum power speed, aerodynamic relationship for parabolic drag polar. Module 2 consists of the cruise performance. In that we have the maximum and minimum speed in level flight, range and endurance with thrust production and power production engines, cruise techniques, constant angle of attack, constant Mach number, constant altitude methods, comparison of performance, the effect of weight, altitude and the temperature on the cruise performance with mixed power plant. Then Module 3 is about the climb and descent performance, importance of climb and descent performance, climb and descent technique, generalized performance, analysis for thrust producing, power producing and mixed power plant, maximum climb, gradient and the climb rate, energy height and specific excess power, energy method for optical climb, minimum time, minimum fuel climb, measurement of best climb performance, descent performance in aircraft operations, effect of wind on climb and descent performance. Module 4 is lateral maneuvers, turn performance, turn rates, turn radius limitation factor for turning performance, instantaneous turn and sustained turns, specific excess power, energy turns, longitudinal aircraft maneuvers, the pull-up maneuver, the maneuver envelope, significance, maneuver boundaries, maneuver performance of military aircraft and transport aircraft. Then we have the safety requirements, takeoff and the landing performance and flight plan. Estimation of takeoff distances, the effect on the takeoff distance of weight, wind, runway condition, ground effect, takeoff performance, safety factors, estimation of landing distances, the discontinued landing, bulk landing, air safety procedures and requirements on performance, fuel planning, fuel requirement, trip fuel, environmental effects, reserve and tankering. These are the module 4 and which we will be covering in this module. So before I should start my first lecture, it is just introduction about the flight mechanics course. In this we have the knowledge competency level. In that apply is, if you take the 6 outcomes, more are from apply level, understand is 1 and the analyze is 1. So if you see out of this thing, it may be 15% will go to the analyze level. Most of the students should be in the apply level. Few the weak students may be in the understand level. These are the books which I will be referring. That is Anderson JD Junior Aircraft Performance and Design International Edition, McGraw-Hill's first edition. SL by ME Aircraft Performance Theory and Practices, AIAA Education Series, AIAA second edition 2000. Thank you very much and be tuned for my next lecture about the flight mechanics. Till then, goodbye and see you. Be tuned, I will be covering the full flight mechanics. I will have some 65 lectures as of now.
Like, share and subscribe. Hit the bell icon for more updates.